So we have over 3,000 XTS systems running in real applications globally across the world. Currently, our limitation is around about 6 kilos. However, Alex is going to talk about how we've extended that with their latest development called the High Drive.
Yeah, so High Drive really is a development that we've worked on to really sort of, extend the capability of XTS further. We've already talked about the standard XTS and how the sort of Hepco steel guide system really sort of maximises durability. But when it comes to low capacity, we want to really maximise that. So the High Drive is essentially a larger mover with larger bearings, and we can actually mechanically link multiple movers together, both on the same track, but also High Drive Plus, which allows us to stack one track above the other and have up to 4 movers mechanically linked. But, Brad, I mean, we talk about sort of the loads, load increase, but how does that actually affect the accuracy and repeatability of the system?
The short answer is it doesn't. We still can achieve an accuracy of 150 microns with a repeatability of 50 microns. Our dynamics change, of course. You've got more mass moving, so we're not moving as fast. However, it's more efficient because we're sharing the load across different coils. So it's actually a very efficient drive system.
Yeah, and just to give you an idea, in terms of low capacity, we said the sort of standard system is about 6 kilos, but the High Drive system, potentially we could be looking up to 20 kilograms on a single mover. Obviously, when you get to those sorts of payloads, then you have to reduce the dynamics of the system, I think both probably from a mechanical and an electrical perspective. But the other thing we can, as I said, we can mechanically and electrically link those movers together. So you've got 2 movers mechanically linked on the same track. Payload goes from 20 to say 40 kilograms. And then if you've got another track below, then you're potentially looking up to 80 kilograms. But fundamentally, also, if you have the double stack track, the High Drive system, it actually allows us to increase the moment capacity as well. So you can actually have your payload stacked out quite a way from your system. So, Brad, I mean, how does this sort of electrical how have you increased the electrical drive force on this system as well?
Well, we have more magnets on our passive movers, so that gives us more current to deliver to the mover. But tethering the movers together is incredibly simple with our system because, as I say, with our TwinCat system, it's all running in one PC, and it's a simple gearing function. It's a simple electronic gearing function. We couple them together, they're electrically coupled together, we don't lose accuracy. The other benefit as well is that we can very accurately couple them together because we use EtherCAT down the backplane. And EtherCAT, if we know about EtherCAT, is we have a distributed clock system which couples the movers to nanoseconds.
Sounds easy. So what are we actually talking about in terms of drive force? Because we know we've got this new 10-pole magnet which is fixed to the mover.
So that's 210 newtons.
Okay, and that's a peak force.
Peak force, 210 newtons.
So yeah, we're looking at what? 800 newtons
800
roughly-ish of sort of driving force. So yeah, really sort of increasing the capability of XTS
and it moves into new markets. The bottom line is that this increased load capacity now moves us into a whole new market, potentially a whole new market.